Right. So today we are going to start doing something. We're going to start using 3D objects today. So we haven't really done that yet. And I want to talk about some of the notation that we've been using previously. So when I have y equals x cubed plus 4x squared minus 10, and we do dy dx, then we get 3x squared plus 8x, right? This particular, let me get another color. This particular notation is saying this is the difference in y with respect to x. If I use different letters in the question, I need to use different letters here. So we're going to start using equations that are based on volume, which means we're going to have things like sometimes x, but sometimes L, sometimes H for height, sometimes V for volume. So if I write that the volume is, I'm just going to make something weird up, 4h squared minus 20h plus 4, when I write the derivative, I'm going to write dv dh because I want the difference in v with respect to h because we're not using y's and x's this time. So then I would have 8h minus 20. Do you get what I'm doing? So don't just write y's and x's because that's what we're used to doing. This top letter belongs with whatever that is, and this letter is whatever this is. So in this case, this letter is this letter, and this letter is inside the equation, right? So don't just write dy dx because you're used to it. We will be using different letters today. So let's do an example where we are going to use v's for volume. I'm going to talk about a box. So I now have a 3D box. Okay, so yes, I know I'm amazing. So this is an unknown number of centimeters, and so is this. And this is also a different unknown. So this makes the base. I've clearly drawn this horrendously because what shape is this? Excuse me. Okay, so the base is a square. This is a square-based cuboid is the word that we use. So this is a cuboid, but it's not a cube. Yeah.
You change that side x and the yeah.
Yeah, that's true, actually. All right, let's just pretend I've done a good drawing as we usually need to do. So I am going to say that the volume of this is x times h, right? You with me? So that is x squared h. That is the volume of this shape. What if actually, actually, I don't want to do volume, do I? I didn't read the question properly. I would like to do surface area. All right, so the total surface area is 100 centimeters squared, right? So what I can do is I can think about the spaces. I have two lots of x squared, right? I've got the bit on the bottom, right? My base as well as my top is going to be 2x squared. And then I've got these four sides that are all equal. Those four sides are going to be, so 100 equals 2x squared, the base and the top, and then the four sides, which is just x times h. Are you with me? So they are going to ask me to express h in terms of x. What do you think that means, Josiah?
Get h by itself.
Yeah, get h by itself. Express h in terms of x. So I'm just going to rearrange this to get h by itself. So then I'm going to divide. So 100 minus 2x squared divided by 4x equals h. Now this can obviously be simplified. I can divide these, so I get 25, and then divide these, which is... Are you seriously telling me to put decimals in a fraction? How much do I hate you right now? Oh yeah, okay. That's okay. So what I'm going to do is I'm going to write them separately. Okay, let's write them separately. So this is going to be 25 over x minus x over 2. Are you with me?
Yeah.
Okay, So this is me rearranging this to express X in terms of H. Okay, now what I want to do is find my volume. So let's change colors and let's do exactly what we actually, let's go backwards. Let's go over here. So volume is going to be 2 lots of X squared plus 4 lots of XH. We already know that. That bit's pretty easy. All right, but what I want to do is, what do you mean? Oh, it's not what I wrote before, is it? Thank you. X squared H. Okay. So what I want to do now is I want to write the volume in terms of X. So what should I do?
But H, some H in.
Yeah, great. I've already got H in terms of X. So I'm just going to put that straight in here. So I've got H is 25 over X minus X over 2. So that means I get 25X minus, oh my goodness, stop it. X cubed over 2. Or you can write this as half. Don't write it as 0.5 because stop using fractions. Okay, so the other thing that we can also do then is say, right, we want to know the maximum possible volume of this box. So we're going to use derivatives to actually find something practical now. We haven't really done that yet. So I'm going to say, based on this information, I would like to know when the maximum value of X exists, right? So X to get the maximum V, right? So what value of X gives me the maximum volume? Does that make sense? So if I find, so when we're finding, I'm just going to draw a little thing. If we're finding graphs like this, don't we want this? If this is V and this is X, whatever value of X this is gives us the maximum volume, right? Make sense? So that's really what we're practically about to find. We are finding the turning point of this graph, which is a maximum turning point because that value of X helps us maximize the volume. This is actually, I mean, this might sound like a stupid, boring question, but this is how businesses maximize profit. If you are selling something in a box and or like a container, let's say that you're selling liquid or protein powder because you want to be a gym bro, like whatever it is that you're selling, you need to, if you have a shape, you want to maximize the space. So you use the least amount of materials to make the most profit, right? This stuff is quite practical when it comes to business. You pay people to do this kind of stuff. All right, so let's work that out. So if the volume is 25x minus, I'm going to write it like this, half x cubed, I now want to find dv dx, right? There's no y, we're doing volume and x.
25 minus 3 by
Okay, 25 minus 3 over 2x squared. This is my derivative. Now I want to solve for x. When the derivative is 0, that's when the gradient is 0. That's where the turning point exists. So I have this. So then that means that 3 over 2x squared is 25. X squared is, I totally did this already, and I don't remember where my answers are. They're probably in my bag. Did I do it with my book? It's my book again. Nope, wrong book. Oh well, great. Okay, so 25 times 2/3. 25 times 2/3 is 50 over 3. Okay. All right, so we've got 50 over 3. So what do I do now? Good, square root it. Do I take positive and negative?
Oh,
Why not?
because
Why?
you can't have negative. You can't have negative, right?
Okay, because it's the highest point, but what we're really trying to say is you can't have negative distance,
Yeah.
right? So in terms of practicalities, because this is a 3D spatial question, negative distance makes no sense, so I'm just going to stick with positives. So what's wrong with this at the moment? Is this the right answer? Why is it incomplete?
Plus 2 plus
No, the third's okay. What's wrong with this in its form at the moment?
I want to say.
It's got an irrational denominator, right? So I'm going to rationalize my denominator. So I've got root 150 over 3, which is 5 root 6 over 3. All right. So this is now the maximum. This is the right value of x to get the maximum volume. So if I was to draw this, that would be 5 root 6 on 3. That's the x coordinate of the volume. Okay. What else do I need to do? Okay, what if I was asked to find out if this is a minimum or maximum? First of all, obviously it's a maximum. You should be able to tell. But if you couldn't, like if you look back at our original equation over here, this is a negative quadratic, which means it has a maximum turning point. But how do you tell if it's a maximum turning point if you don't know that, Josiah? If you don't know that, Josh.
Second derivative.
Good. So second derivative, if I find my second derivative, so d squared v over dx squared, what's the second derivative of this?
It's minus 3x.
Good, minus 3x. Now, if I say that minus 3 times that value of x that we just put in, whoops, that's a 6. It doesn't really matter what this is. It's negative, right?
Yeah, so
Negative 3 times anything. Right, so it makes it a maximum because the answer is negative. Anything less than 0 is a maximum turning point. But frankly, you should know that because it's a negative quadratic graph. All right, let's save that. Let's do another one. Yeah.
That's not right.
What do you mean?
The probably is not that. It's supposed to be where the x sits on.
No, because this is the derivative. I'm solving the derivative. I'm not solving the original.
So then if it doesn't do points. Oh yeah, what if there's, I don't have.
The original graph has 2 turning points.
Yeah, it is derivative, right? Y equals 0 should be that point be on the y axis.
Oh, I see what you're saying, but no. I'm saying the derivative is 0. No. Oh, okay. Yeah, actually, no, you are right, actually. It is giving us this maximum point. Sorry, you are right. It's not that point at all. It's this point over here that it's giving us. This is the maximum value of x. Yeah, sorry, you're right. Okay. Let's do one more. So